Welcome everyone. Welcome to this eighth week of quantum computing in a nutshell. If you are watching this video on YouTube, you can leave your comments in the comment section. Also, you can reach me out in the respective Discord channels and other ways. In this lecture series, on our eighth week, we are going to discuss about a quantum finance AI model which will be focused on various mathematical manipulations as well as deep machine learning concepts. First of all, I would like to thank Open Science Labs for this wonderful opportunity to take this lecture series into a success. Hopefully, we have got a ton of positive signs from international forums, and hopefully in the upcoming weeks, we will going to discuss various research-oriented topics in terms of quantum computing. For this week, for a short brief, we are going to discuss about a quantum-based finance model, uh, which will use various kind of mathematical formulas and theories, especially in terms of Nash equilibrium theory. We are going to use this week. First of all, let me start the program by itself. First of all, let me screen share once. Okay, I share my entire screen now with you. Okay, I hope my screen is visible to everyone. Let me first show my Linux terminal here. I have built a quantum computing based algorithm here using Python as well as QISKit. Sorry, in this part I'm using Pennyland. Also, I'm using PyTorch for machine learning, Matplotlib for simultaneous representation, and other Python-based tools for machine learning, as well as other programming stuff. And first of all, we will see the end product here. This is my end product you are seeing right now. I think maybe a disconnection from my wait, let me check once again. Okay, now it is working fine. For this week, I have built a new quantum based finance model using Pennyland as well as PyTorch. You can see there is three channels. First one is red channel, which is getting an input from A0. It is in green channel, we are getting an input from the A1. Blue channel, we are getting the input from the A2. For the people who came from financial end, they can easily understood what I am currently supposed to explain here is that uh, I'm just simulating a AI based model. For this, we are currently using three channels. The red channel is for selling, and the blue channel is for holding your stock, as well as the green channel is for buying new stocks here. And we are using Nash equilibrium state pure strategy, as well as mixed approach, as well as many other Nash equilibrium based approaches which we are using right now here. For the simulated data, we are basically using a real world kit using Arduino UNO board, as well as we are using three light emitting sensors, or in your terms, we are using three LEDs for our setup. I hope you can see this onto your screen. We are using three LEDs here and an Arduino board. Basically, we are getting the input from my serial connector, which is connected here. You can see in my terminal, the hardware is connected into my serial port TTY USB 0 with a baud rate of 9600. And this is the stuff which I have done here. Uh, I'm doing this machine learning for quite a bit of a time. Initially, it showed various trends, but now the model is kept learning the patterns of these LEDs, and I just manipulated that this input is getting from the blue LED is represented as holding the stock, as well as the trend coming from the green LED is converted into buying new stocks, as well as the red LED for selling the stock. Basically, what we have done here is we have converted a physical sensor data into a manipulated share market data, and we have built a machine learning above it, and we are fitting this into a quantum circuit using Pennyland. For that, initially, if we are studying or dealing with this kind of real world high noise data using PyTorch or any other mm, machine learning algorithms, we would have to need a lot of we would have to need a lot of computational power for classical computers for using PyTorch or Pennylen or any other algorithms for an instant. But here we are using quantum based approach. We are using a 36 dimensional Hilbert space for these calculations. We have built it using Pennyland, and basically what we are doing here is we are just trying to crack those patterns of what we are getting from a physical source of light, and we are learning the pattern, and we are trying to make decisions in terms of the fluctuating market trends, mostly in terms of financial quantum manipulations. The professors from Harvard or any other international institutions mostly don't take this kind of approach. They use see pre-existing marketing data or something else. But what I have done here is a three-dimensional real-world noise into a 36-dimensional data set, and we are analyzing those patterns, and we are just creating an output decision out of it. This is what we have done here in this entire lecture for this 8th week. Apart from this, you may think, what does the novelty is had? Well, basically, in the current world of quantum AI, we are still developing AI models. We are still trying to develop new AI models using various frameworks which we are currently having, like QIS Kit or Pennyland or any other frameworks which we are currently dealing with. But we still don't have the that much of computational power to handle those complex problems. So what we are basically doing here is we are just using this Pennyland code to observe the real world data And we are doing quantum Fourier transformation functions here to split those complex data into tiny, tiny pots. And we are studying those complex patterns and trying to manipulate it using machine learning. We are basically doing, we are just feeding the data into directly into the quantum circuit. We are converting them into Hilbert spaces. We are then using the machine learning part, we are learning the data patterns, and we using the Nash equilibrium method, which is developed by the Nobel laureate, the Abel laureate mathematician and a finance expert, Nash, John Nash, who also developed the game theory, who is behind the development of the game theory. We are basically doing this stuff using Nash equilibrium formula. Basically, what we have done here, we have combined mathematical formulations like quantum Fourier transformation and other stuff. We have done entanglement as well as superposition using these controlled C naught gates using the penny line simulations, which is a physics and a quantum computing part. Also, we have combined uh, this kind of an Arduino UNO hardware in the loop structure. We had used the hardware in the loop structure, uh, which is comes under electronics. We also combined the financial formulas like the game theory as well as Nash equilibrium formula. We have just created a quantum finance AI model, which is a hybrid quantum finance AI model here. Uh, well, basically, it is still under a development stage, or maybe it is just a prototype which we have developed here. But in the future, we can expect that it could also be a potential uh, way to analyze those complex patterns appear in the share market or any other ways. Basically, for those people who don't know about the Nash equilibrium formula, Nash equilibrium states that basically, if two drivers are traveling in a highway, they have to choose, they have two paths, maybe A and B. If most of the drivers, like let me consider 500 drivers are driving in a highway, if 500 of them uh, choose the A path, it will create a traffic jam. If 250 of them choose the A path and 250 of them choose B path, there would be no uh, need for a traffic jam in the way. In the same way, in the market field, we should have to be less competent in the market. If some stock is rising, it means some is dropping in the market. It may happen volatilely. And uh, the market is still an unpredictable game. Trading is still an unpredictable game. What we have done here using machine learning, using quantum machine learning, we have just created a manipulating model which can able to simultaneously hold the stocks or maybe sell the stocks or maybe buy new stocks. We have done this using Nash equilibrium method. We are using quantum machine learning using PyTorch and Vanilla, and we are using Matplotlib for this so-called visual representation. And we are getting the data just from a real world, just from a real world LED. That is the main thing. That is the core thing. Because we are not fitting the real world share market data. It may cause overfitting or underfitting, but what we are doing is we are fitting a real world photonic data. We are doing a photonic data analysis, and we are considering them as a share market data. So this model is can be able to handle way more complex things, uh, way more complex financial patterns maybe in the future. And you can see that it is kept showing the analysis. Currently, this is a transactional fluctuations here. It is observing that the data is coming out from these LEDs showing trans- transitional fluctuations because the lighting inside the room is kept changing every moment. Let me show an example here for you. Let me open my torch here. You can see I will directly project my torch light into this setup. Yes, you can see that there is a ton of fluctuations in the red lines, and it is kept changing its positions. The values are kept changing. The loss rate, the circuit balance is kept changing. It is scrolling to, because there is a ton of fluctuation, it is scrolling to don't buy new stocks, and it is fitting like 0.6 percentage. It is saying like you have to hold the stocks. Why we are using 0 to 1? Because we are determining this in a probabilistic way. The quantum strategy prediction, it is based on a probabilistic way, which we are doing here. Let me turn off the torch. I think this is unnecessary now. I hope you have understand the basic fundamental concepts associated with this wonderful quantum finance machine learning model. Maybe you think like it is not a very fancy thing to know. It may not sound like a industry level project. You are just using some LEDs and a few lines of code. What does it mean in terms of machine learning or in terms of modern AI? Basically, let me reveal my code, and then only you will got the idea what I have done here. Uh, Let me reveal my code. This is my code which I have written for this entire project. I am also giving this code in open source also. One second. Basically, what we have done here is we are importing time, system, and math libraries for basic fundamental calculations. We are using NumPy for array manipulations. We are using neural networks using PyTorch. We are using PennyLand for quantum machine learning QML circuits. We are using matplotlib pyplot for plotting purposes. We are using matplotlib grid space for this kind of grid space animations. And we are also using func animation. We are using collections for impaired tech, logging for font management, for handling errors. Here is our hardware configurations and settings we have done here. The window size is 120 bits. A number of qubits which we are using here is 4 qubits which we are using here. The number of layers is 3. Uh, and the thing, the machine learning layer which we are creating is a 36 dimensional machine learning Hilbert space layer which we have created here. Also, the learning rate is very low. Since it is a very sensitive data, I have set the learning rate to be very, very low, 0.01. And the serial port, which is used as TTY USB 0 for connecting this Arduino board here. We are using QML device for creating and initializing these quantum circuits. We are using quantum xenon gates here for this 4-bit operations. We are controlling these RGB things into flattened data, flattened input data, and we are reversing this information and feeding this to a long short-term memory, a quantum neural network using PyTorch. Here we are giving 3 data. We are set at the hidden size as 16. We have also set some dates. We are using a sequential new linear neural network here for this qubit analysis. Also, in our main file, we are doing this kind of Nash manipulations here. We are considering those Nash equilibrium conditions here, and these parts are mostly used for uh, the plotting purposes. In below, we have set the quantum model forward and backward paths, which we will going to discuss in the future. Here we have initialize the Nash state functions here, what is the decision we have to do, what should the machine learning model should have to do when it is experiencing a variation in the market or something else. Like if I adjust these LEDs, I hope there should be a fluctuation in the line. Yes, you can see when I pour some light onto it, you can see there is a change in the connections, and it is kept changing these values, the circuit balance values and other stuff here. Like it is predicting the complex things, but here we have just used a very simple Nash state prediction model because I'm not so much great in terms of finance or trading. I have just used this approach for just a manipulation or simulation purposes only. Well, this is the code which I have used here. Afterwards, I would like to thank Open Science Labs for this wonderful opportunity which they have provided to take this quantum lectures to another level. In the upcoming weeks, I am going to release some preprints of my research paper in terms of quantum machine learning as well as recurrent neural networks uh, based on quantum circuits, which can be called as a hybrid recurrent neural networks, which is both combined with quantum as well as artificial intelligence. And also in the upcoming weeks, I will going to give you a ton of brief information about upcoming researchers which are associated with quantum information, quantum computing, and quantum mechanics as well. And in the upcoming weeks, we are going to discuss a lot of theory and mathematical stuff. And we will going to break down our code into tiny, tiny pieces so people can easily understand what I am trying to explain to you. And hopefully, I thank everybody who joined this session and uh, keep supporting me toward this journey. Also, I feel that in the future, my every viewer or maybe my every person who is taking these classes would publish a new paper in quantum computing or may become a very good quantum physicist or quantum computing expert. That will be my wish. And also we are going to launch various projects in uh, open science labs, and we are also looking for potential affiliations from ABS and as well as other international forums. And I'm also got a quantum computing introductory book which is published by a professor from University of Michigan. I will share the book once I read it entirely and I got a better idea. It is also available in open source. That is a very good sign. And I will share the book in the upcoming days. Uh, the people who are watching this video on YouTube, live or maybe a recorded session. You will find the Discord channel links in the command box or the description box. And also, you can register your doubts and stuff in the Discord channel as well as the command box. Also, if you are looking for a professional advices or maybe consultations in terms of quantum computing and quantum mechanics based approaches, you can directly contact me at your preferable time. Uh, I can give my knowledge which I have right now. Also, uh, maybe some people think that why I'm doing this for while I'm having a very not a very great English accent or maybe not that much knowledge in terms of quantum computing. Well, basically, I am doing this not for the people who already know about quantum computing or not for the people who are already doing international stuff, but I'm doing this for people who have a very limited knowledge in terms of quantum computing and have fascination to learn more and more things, because this quantum AI models will rule the future in the upcoming months or maybe in the upcoming years. So we have to learn it, we have to experience it, and we have to adopt it, because it is a race for life. According to Darwin's theory, if we have the qualifications to live, we will succeed, or otherwise, we will fail in the race. That is the same thing for quantum computing. We have to learn it, otherwise, we will fail in the race. So, I hope every one of my viewers and every one of you will succeed in the future in the quantum field, in the quantum computing field. Anyway, thank you for this wonderful session. Uh, we will meet in the next week on August 22 in the same link on meet.gis.si/OSL Quantum Lectures. Also, you can reach me on the Discord channel. Also, I will have a Tamil session on this thing on the next day, 16th 8 2026, almost 7 p.m. Indian Standard Time. Also, we will going to meet in the August 22nd at 10:15 p.m. Shortly at 10:15 p.m. Indian Standard Time. I hope this session is an interesting one for everybody. Hope you hoping to meet you again in the next week. Thank you, everyone. Thank you for joining this session. Thank you for learning these kind of new things.